आयतनम् आयतनवान् भवति यः पर्जन्यस्यायतनम् वेद आयतनवान् भवति आपो वै पर्जन्यस्यायतनम् आयतनवान् भवति.
Since ancient times, Indians have realized the importance of water. Therefore, water is also called as Jeevan, which means life. The Water Resources Department, Government of Maharashtra, is dedicated to optimize these water resources in Maharashtra. The primary functions of WRD of the Government of Maharashtra are survey, investigation, planning, designing, construction, maintenance and management of surface water resource projects, including hydropower projects. The Hydrology Project Wing under the Chief Engineer Planning and Hydrology, Nashik, has been established with the objective to extend and promote the sustained and effective use of hydrological information system by all potential users concerned with water resources planning and management. The state of Maharashtra is divided into 5 major river basins. They are Krishna, Godavari, Tapi, Narmada and west-flowing river of Konkan region. The Krishna river basin, of which Bhima is a major tributary, covers an area of 70,000 square kilometers. It experiences highly variable rainfalls ranging from 6,000 millimeters in hilly region to 400 millimeters in lower plains. 46 multi-purpose reservoirs located in the basin are conventionally operated as single entity and the data is transmitted manually. This results in considerable time lag for decision making in emergency flood situations and preparation thereof. Therefore, in the year 2005 and 2006, when Krishna Bhima sub-basin experienced a flash flood, it led to heavy damage to lives and properties in the basins. RTDSS, that is, Real-Time Decision Support System, is developed for Krishna and Bhima Basin in Maharashtra on a pilot basis by Planning and Hydrology, Nashik, under the World Bank-aided India Hydrology Project Phase 2.
Real-time decision support system developed for Krishna and Bhima Basin can be described as a milestone in the progress of State Water Resources Department, Government of Maharashtra. This system comprises highly advanced computer technology and is implemented first time on pilot basis for flood management. This system developed is very useful not in the flood condition but for the long-term optimization of the water resources for efficient management of water resources. On the banks of the river, there are large cities like Pune, Pandharpur, Kolhapur, and we can get the flood forecasting by measurement of the river levels automatically with the help of river gauging stations, and we know how much area is flood prone and we can prepare to face any flood situation in monsoon.
For development purpose, the system is principally divided into 2 components, that is, Real-Time Data Acquisition System, that is, RTDAS, and Real-Time Streamflow Forecasting and Reservoir Operation System, that is, RTSF and ROS. Let us see the details of RTDAS. RTDAS consists of installation and commissioning of various automated sensors to record various hydro-meteorological data and to transmit it in real time through appropriate telemetry to data center established at Sinchan Bhavan, Pune.
This real-time decision support system project is a big achievement for planning and hydrology in Nasik. The system has been implemented through World Bank-aided Hydrology project phase 2. The real-time data collection through the system is forming reliable database for Krishna and Bhima Basin. The system is working successfully since June 2013 and now well in position to guide the flood monitoring engineers to establish a real-time decision support system in their area. Under the National Hydrology project recently launched and considering the usefulness and success of the implementation of this pilot project, it is planned to implement RTDAS under proposed NHP throughout Maharashtra state for flood monitoring, forecasting, as well as for basin water planning and drought mitigation.
The system work includes real-time data acquisition and transmission of hydro-meteorological parameters like precipitation, river gauge, reservoir level, spillway gate position, canal gauging, temperature, humidity, atmospheric pressure, wind direction and speed, and solar radiation. The system collects data time to time and transfers that data as input to the decision support system. Benefits of RTDAS includes cost effectiveness, high frequency data, better ability to detect problems with measurements, and faster access to data and consistency in measurement. Out of the total 249 RTDAS stations, there are 127 automated rainfall stations, 39 automated full climate stations, 37 real-time river canal water level stations, 46 reservoir water level sensors, 26 dams with 175 spillway gate position sensors. Data is collected and transmitted in real time through VSAT or GSM telemetry to data center at an interval of every 15 minutes. On field, the sensor is installed with all its accessories. The accessory includes sensor itself, data logger, batteries, antenna, modems, solar panels, etc. The small hosting called as gauge house is constructed on field to accommodate the data logger. There is a provision of fencing also for additional security. The sensors are placed on location following the WMO norms. Let us see more details of each sensor used in RTDAS of Krishna Bhima Basin. Rainfall sensor. This sensor is built to deliver the high-level accuracy of rainfall intensities. Each of this unit has a collector funnel. Rain sensor has an integrated siphon control mechanism which helps to deliver better accuracy. Radar water level sensor. Continuous and non-contact level measurements are the key features in radar level sensors. This sensor is built for water level monitoring. The radar works by releasing high-frequency electromagnetic energy which is reflected by water surface. Shaft encoder level sensor. Water comes into the stilling well through inlet pipes from the water source. As water increases and decreases, a float moves up and down with the water level. The shaft encoder converts the shaft rotations to an electronic signal which will be measured by a data logger. Bubbler level sensor. Bubbler level sensor is mainly used where there is no bridge or other structure with direct vertical shot to the water surface. This sensor is built to maintain pressure in the internal tank, for which it uses battery-operated compressor. This system consists of a microprocessor which determines how much pressure is needed in the tank to produce constant bubble rate. Weather sensor. Weather sensor is a compact, light-weighted style. It utilizes Gill ultrasonic technology to measure wind speed, wind direction, temperature, humidity, atmospheric pressure, and solar radiation using an industry-standard sensor. Gate measurement. It is a specially designed measurement system for radial, vertical, and screw-type gates. It provides the opening of the gate. All the data and information collected by the above equipment is transferred to data logger. Data logger. Data logger plays a very important role in the real-time data acquisition system. The function of the data logger is to interface with all the sensors and store the data with time stamping. It can interface with various wireless networks. The information collected and data needs to get transferred to the data center, for which a medium of communication is required. In RTDAS system, GSM or GPRS and VSAT data communication network is used. GSM or GPRS communication. With the help of GSM or GPRS technology, the user can achieve wireless communication up to far greater distances at a very low cost. GSM or GPRS communication is useful only for monitoring of comparatively non-critical stations and parameters. VSAT communication. The VSAT communication covers a wide geographical area. It is independent from terrestrial communication. It is built on a very high infrastructure so that it has a rapid network deployment. VSAT is very useful in the event of disasters, which serves as a medium of communication. For RTDAS in Krishna and Bhima Basin, all the 46 reservoir stations have been provided with VSAT telecommunication.
The real-time data acquisition system gives us various parameters like rainfall in a basin and reservoir operation data at a glance. This helps for proper flood management and warning to flood affecting areas well in advance by 72 hours.
The real-time data of various hydrological parameters received through this website gives us on-site situation immediately. Model developed through this system gives 3 days forecast of rainfall, reservoir inflow and water levels and discharges in the rivers. This helps us in proper flood monitoring and early warning to the probable flood affected areas.
Data center. The data communicated through telemetry is collected at the data center established at Sinchan Bhavan, Pune. The data center is the core of the whole system and is responsible for receiving data from all the remote stations. The application software running on the communication servers validates the received data from its upper, lower and data delta limits. Based on the received data, alarms and events will be generated and displayed on the web screen. Graphical user interface in the form of web page is developed to disseminate the RTDAS data through the internet on the website www.rtsfros.com/Mahakrishna. On the home page of the website, there is a link for real-time data. The geographical user interface GUI of this real-time data is divided into 2 parts as Krishna Basin and Bhima Basin, showing drop-down of Automated Rainfall Station ARS, Automated Full Climate Station, Automated River Water Level and River Discharge Station, Automated Reservoir Water Level and Outflow Discharge Stations, an Automated Canal Water Level and Canal Discharge Station. The real-time data is updated after a 15-minute interval on the web page. In RTDAS, within a short time, it transfers information from every station to the data center. RTDAS is such a high technological based system that gives constant updates about the situation. So in a disastrous situation, it is a reliable and a time-saving medium of data communication.
RTDAS for Krishna and Bhima is maintained and operated by Hydrology Project Division Pune. The sub-divisional field offices at Satara, Sangli, Kolhapur, Pune, Solapur and Shirur are taking care of RTDAS stations. It is a big challenge to keep some of the remote stations in operations and to protect them from theft. As this is a pilot project, we are learning the various techniques to operate and maintain the system, which will be helpful for further extension of the same system throughout Maharashtra.
Let us move to the next part of RTDSS, that is, Real-Time Stream Flow Forecasting and Reservoir Operation System, RTSF and ROS. The Real-Time Stream Flow Forecasting and Reservoir Operation System, RTSF and ROS, is built upon the Mike 11 modeling system, which comprises the hydrological rainfall runoff model, the hydraulic river routing model with the data assimilation process used in real-time flow and flood forecasting. The core function of the mathematical models in the RTSF and ROS is processing of the meteorological forecast data from external sources, real-time and historical data stored in the system into quantitative forecasts of the inflows to the reservoirs and flood forecasts in the river on the downstream side of the dams. The model is designed to supplement the existing decision-making in WRD, which to a large extent is based on decades of experience of operating the dams and on historical data and derived statistics.
On behalf of Chief Engineer Planning and Hydrology Nasik, the entire execution of this pilot RTDSS project is done by Basin Simulation Division Pune. The experience was innovative, value-adding and very inspiring. Validation of RTDAS and fine-tuning of RTSF-ROS model with dissemination of results through website are major activities of BSD Pune. However, fine-tuning of RTSF-ROS is a continuous process and is bringing the model closer together and to increasing its accuracy.
The main features of RTSF and ROS: Knowledge-Based System (KBS). All the data used for modeling purpose are stored and maintained in knowledge-based system. KBS is designed and installed with all historical hydro-meteorological data, river flows and levels, irrigation data, available satellite images, and other GIS data collected and populated in the database. Real-time stream flow or flood forecasting model. It consists of 1. A hydrological model, rainfall runoff model, for generating runoff from a number of catchments schematized in 2 sub-basins. 2. A hydrodynamic model for routing flows through the river and reservoir system to compute flows and water levels. 3. A real-time flood forecast model for computing stream flow and flood forecast for a period of 3 days from the time of forecast. 4. A river basin water resources simulation model for water allocation, including optimizing water use and reservoir operation. The hydrological model, rainfall runoff model, is used and coupled with the Mike models, forming part of the integrated modeling system. For modeling purpose, the basin has been divided into 122 sub-catchments. Hydrodynamic model. The Mike 11 hydrodynamic river model takes the rainfall runoff from the NAM and carries out a continuous routing of the flows and flood waves through the main rivers and reservoirs. The river schematic with 1,550 cross-sections and 46 reservoirs in the basin is used for hydrodynamic model. The model is calibrated using data of year 2006 floods. Stream flow and flood forecasting model. The model provides a quantitative response to the predicted weather forecast. The output from the hydrological model is fed into the Mike 11 hydrodynamic model for forecasts. Mike 11 hydrodynamic model, incorporating data assimilation at all the real-time discharge and water level stations, prepares real-time stream flow and flood forecasting. The model has 3 days advanced forecasting system. Forecast is available daily at 12 noon and 5 p.m. in the monsoon season. The model forecasts rainfall in sub-catchments, inflows, outflows, and water levels of reservoirs and water level and discharge in the river at various locations critical from the flood point of view. Fine-tuning of the model is a major activity and is in progress at the data center.
All the real-time data is received, validated and stored at data center established at Pune. RTDAS data is available 24/7. However, the RTSF and ROS model is run twice daily in monsoon season and results are uploaded on website for stakeholders. At present, validation and fine-tuning of the system is in progress at data center Pune.
Reservoir Operation Guidance System. The simulation models of RTSF and ROS are integrated with a suite of optimization tools for optimum operations of the reservoirs, both for the short-term operations during the flood season and for round-the-year optimal water allocation. The first type of optimized model developed is for short-term optimization, which is aimed at providing improved reservoir operation guidance during floods when an inflow forecast is available from RTSF and ROS. The second type of optimization model developed is for long-term reservoir operation guidance for round-the-year water allocation for irrigation and water supply considering hydropower requirement. The third type of optimization model developed is for seasonal operation of the reservoirs to minimize downstream flooding while considering the need of keeping the reservoirs full at the end of the rainy season. Model Forecasting and Operation System Interface. A user interface is developed by integrating the described models for operational forecast and for providing reservoir operation guidance, scenario management and flood warning and dissemination. Communication and Information Management System. All results from the forecast simulations are presented on the website www.rtsfros.com/Mahakrishna with a link to real-time forecasts. The web display of station status takes place via Google Maps with all zooming to street level and provision to show data on satellite images, road maps and on terrain maps. The web page has provision for display for 4 different data types: discharge, water level, precipitation and data from reservoir, water levels, inflow and outflow.
The real-time flood forecasting system developed for Krishna and Bhima Basin facilitates the scenario generation for individual reservoir and also for integrated reservoir operation of multiple reservoirs. This system also facilitates the forecasting of safe releases through dam and its effect on downstream area, taking into account the rainfall in the dam catchment, inflow into reservoir, rise or fall in water level, reservoir operation schedule, water allocation for different utilization through dam and river water levels at critical points along the river. Thus, this system is definitely useful for releasing safe flow through spillway. The system proved to be very useful for me and my engineers in handling flood situation concerned with Koyna Dam during year 2016. This system also supported well to district disaster management authorities for handling flood situation in the river basin.
Use of RTDAS and RTSF ROS. The model gives 3 days forecast of rainfall, reservoirs and river water level. This helps the field officers in proper flood monitoring and issues a warning to flood affecting areas well in advance by 72 hours.
The availability of real-time data and 74 hours advance forecast through RTDAS system is found to be very useful. This helps to intimate concerned flood affected area in advance.
Government of Maharashtra Water Resource Department has prepared RTDS and RTSF and ROS system is available for the municipal corporation. And this system found very useful as we are getting sufficient in advance warning of flood situation, which gives us a more time for evacuation of people affected due to flood and leads to a reduction and prevention in property and life losses.
साखरेतील RTDAS प्रकल्पाच्या वेबसाईटवर प्रदर्शित होणाऱ्या हवामानाच्या माहितीचा व पुढील अंदाजाचा आम्हा शेतकरी बांधवांना फार उपयोग होतो. त्यानुसार आम्हाला आमचे शेतीबाबतचे योग्य निर्णय घेण्यास मदत होत आहे. वेबसाईटवर हवामान केंद्राच्या तात्काळ व सहज उपलब्ध होणाऱ्या माहितीनुसार आम्ही आमच्या संवेदनशील पिकांसाठी योग्य नियोजन करू शकतो.
During a flood situation, Using the offline scenario generation facility, any type of scenario can be generated before actual release of water from dam to know the probable flood levels on the downstream side of the river. This was the RTDSS developed for Krishna and Bhima basins. We are looking forward to get such a system implemented in the rest of Maharashtra so that all water resources available in the state of Maharashtra will get optimized. And one day Maharashtra state will become the most caring state in the country regarding this scarce natural resource.